FARO as an organization is into making up 3D laser scanners. I have a very brief presentation here which talks primarily about the organization as such, as well as some case studies where we have used the scanners in India. So as I said, quite compact presentation that I have about FARO, the kind of products that we have, and examples. FARO as an organization has been there in the market for pretty long. I think we have been there established since 1982, and we have been one of the leaders in dimensional metrology solutions. FARO came into 3D scanning in early 2005 or so, and since then we have been making 3D laser scanners for survey and as-built applications as well. We have customers across the globe from the who's who. These are all our customers primarily who deal into dimensional metrology, and we also have customers who, within India, companies like Larsen & Toubro and all these companies are using laser scanners these days for a lot of different kind of applications. The primary product that we have for doing scanning activities is the FARO Focus X series scanners. This is a terrestrial lidar. The features, it can scan up till 330 meters radially from a position where it is kept. Can scan directly in sunlight as well. Has an integrated GPS which gives you positional information for the area you're scanning. Has extremely low noise performance. Basically that means that disturbances are self-modulated by the scanner so that you get precise information what the scanner is capturing. Has an integrated compass. This is another sensor inside the scanner which helps you to orient the scans together. An altimeter sensor, again, which tells you, suppose you're doing scans at different levels, it helps you to understand which level the scanner was in a particular project. A dual axis compensator, again, tells you about the tilt applications and all those things. And we also have a Wi-Fi enabled scanner, which really helps you to remotely access the scanner in positions where you have to keep the scanner and it's difficult for the person to actually go and do a physical start-stop and functionality on the device itself. So any kind of mobile device that you have can be remotely connected to the scanner, and you can completely control the whole of scanner functionalities sitting at a different distance. Extremely portable device. The whole scanner is hardly 5 kilograms in weight, and it's quite compact, smaller than an A4 size sheet of paper. So we're talking more about a single-man survey when you talk about capturing realities around you. Extremely high speed. The scanner is capable of capturing close to 1 million points per second. That's a huge amount of data. So depending on the kind of applications that you are into, you can select your resolution settings. And more importantly, class 1 laser, quite safe for humans to use, so no worries on that front. Talking about the workflow that FARO has, FARO adopts a very simplistic process when we talk about using the scanners. It's basically about capturing the data. It's about processing the data where we talk about different locations and you're merging it together and then giving out the final deliverables. These deliverables can be done depending on, again, depends on the application you're into. What exactly have you captured? These things can be, you can get the final deliverable using the FARO's own 3D softwares or software companies like 3D Systems, Autodesk Solutions, Elysium. All these different third-party softwares really help you to get your final deliverable depending on the applications that you have. So when we talk about capturing, what exactly are we capturing here? We're capturing buildings, we're capturing any kind of infrastructure, we're capturing topographical information, it could be machines or anything. When we come to the process part of it, we're talking about merging all the scans together so that you get a holistic 3D point cloud. You can do your basic measurements in this software, which is the FARO scene, and extract information which is required in that project. And finally, when you're creating the deliverables, which, as I said, are done on specific softwares like Autodesk or maybe the FARO's own software. Suppose you're doing a building scan and you want to create a model. You take example of a software would be Autodesk Revit. You're into plant environment. You could be using an Aviva software. So all this data interoperability is there with the FARO. I mean, whatever data you're capturing can be very easily be taken into all these things and all these different kinds of softwares, and you can create your end deliverables quite easily. The kind of applications we fit into, I mean, these are the kind of very basic applications that I've listed here where we are actually, people are using the FARO scanners quite gainfully. It could be from your civil engineering environment, for your BIM processes, your forensics, again, which is a very big market for us. It's a growing market in India, again, Forestry, heritage is again something which is very important in an Indian context where FARO scanners have been used, are being used again for different projects. Movie industry, again another different kind of an application, but again something which is being used in India for capturing things. Surveying, general survey, shipping, again another application. So these are a basic verticals where FARO scanners are being used. Now coming to some case studies, these are some real case studies that we have done in India. I mean, these are examples where how scanners have been used. This is an example of a building in Bangalore which we scanned. It's a 12-apartment building. What you're seeing right now is the point cloud imagery. This is the point, this is all accurate to 2 millimeters. You can do your, once you have this kind of a data, you can create a 2D plans, elevation plans, or do the modeling of that. These are scanner setups. Now, if you look into this place, because the scanner is so small, it can go into various places. Very easily, it's a single man operation, one single guy just pouring into different places and just doing the start scan on site to capture the realities around you. And this is the kind of deliverable you can expect. There's the whole flat and you can just do all measurements out here. You can create 2D plans, you can do modeling on this. Now, when we kind of compare it to the traditional approach that we have, now we talk about different machines which are already there for measuring, like total station and all. The time taken by LiDAR sensor like the FARO, think about it. Just 4 hours to capture this whole 12-apartment building, a conventional instrument might have taken 2 days. And again, will not have given you so much dense amount of data. Costing pretty less, just need 2 people around. So end of the day, these kind of, this really helps, it could help a potential buyer. He doesn't really have to go to a site. He has a real depiction of the area around him and he can just take a decision based on this kind of a data. Another example of road survey, the scanner here is being mounted on top of a vehicle. And this is the kind of data you can capture when the scanner is on a vehicle. And you can capture actually assets around the scanner. This is the kind of setup that we used where a car was used and we had this accessory, so the scanner was on top. The person inside, sitting inside the car, was able to access the whole scanner using the Wi-Fi which we were talking about. So he was able to access the scanner, take the car, stop at a place, do the scanning, go to the next position and do the next. And the software would be able to recognize all these things together and join to get you a complete point cloud. Again, once this data is captured, you can take it into your relevant softwares. It could be Autodesk or similar softwares, and you can get deliverables like these. Another example of conclusion, how do we conclude this, and how is it really useful? Time taken for doing almost a kilometer of survey using LiDAR would be around 40 minutes. The costing is quite less, and just 2 persons again required. And what you're really getting is not just a few points. You're actually getting a true depiction of how the area looked like around. So it could be once you are doing the LiDAR scanning on a road, probably you also get information on the assets which were there. It could be a lamp post, it could be just about anything, an electrical unit, or it could be just any postal units. So this kind of survey really helps you to capture all these details together at one single time. Another example of a bridge, again, this is again a point cloud which we have taken. This was a scanner kept, if you see, it was not a very hygienic place for sure, but we still had to capture this. So we kept the scanner, it did its work pretty well. Again, the cost advantage, if we talk about it, just 1 hour to capture this small bridge. The applications here could be huge. We, as a country, we have so many old infrastructures which we have no data sets for. This is a device which can be used to get your plans, elevation, and do your, what depends on what kind of studies you want to do. There are a lot of possibilities which come along with the laser scanners. Another example that we did with the FARO scanner was a canal survey. This is the kind of data that you can expect from the scanner. This is again a whole point cloud. This is not any photograph. This is just point cloud which is composed of millions and millions of points. You can do your basic measurements and everything out on the computer screen itself. And again, the example is the same. I think the cost in terms of the time you're spending on the ground is very, very less. Anyone who has not even visited the site can actually feel how the site looked like sitting in his office, because you're actually bringing the site to the computer with this kind of technology. One more example of a mine where the applications could be about deformation, about your volume calculations. This is again a point cloud data imagery that we have captured. Example of a scanner which was kept. This is a scanner. Again, you just keep it in a place, you do multiple scans and combine together to get this kind of data. Whatever you're seeing again is lots and lots of points which are very closely packed together. and you can do any kind of measurements from this. This is all accurate to 2 millimeters. Again, example, I think it takes much less time. It takes very less amount of people to actually do the actual survey. And anyone who has not visited the site as well can still do a lot of calculations, lot of post-planning based on the data which the laser scanner gives you. So why the FARO scanner? Again, as I said, it's extremely easy device to use, easy to carry, quite lightweight. It can be upgraded, as I said. I mean, we have an option where you can put it on a drone to capture things which are kind of not visible from the ground level. You can put it on a car, which I just showed in one of the slides, and still do the scanning. A single-man operation, you don't need a team of 10 people to actually go to the site. It's just about one person actually going around and doing all the scanning. And then it supports most of the softwares which are there in the market already. So depending on what application you have, which kind of industry you're serving, are you doing a building survey, you're doing heritage, or you're just doing a topographical or a mine survey, if you have specific applications, specific softwares that you're already using, you can use the same data in those kind of things. So with this, FARO has a complete solution in terms of having the mobile terrestrial lidar, which is the X-series scanners. We have a handheld scanner as well, which is called as the FARO Freestyle, which actually bridges down the gap. There are some certain areas in a big project which you have not been able to capture with the terrestrial scanner. You can do it with the Freestyle. And then we have the processing software that I was talking about, which is the FARO Scene, which clubs all the different kind of data which is being taken from different sensors to get you a comprehensive point cloud. So this is a very short presentation that I had. I think we have a booth outside, so any questions or any live demos you want, please come across. Thank you so much. Thank you.
Thank you so much. Now, I would request Shri Gunjan Sachdev, Senior General Manager and National Business Head, Panasonic, to kindly share his views with us.